Okay. So now I enter into ANSYS. Let me start with the preferences. So since this is a structural problem, I want to define set the preferences as structural. Click OK. Then I need to allot the type of element. So in the previous case, we discussed about a truss problem. No, in case of truss problem, we consider link elements, and in case of beam problems, no, we consider element type as beam. Both the cases, I choose two noded elements. So in this case, to solve this problem, I want to select the element type as a solid element, solid 2D element. So let's add an element type. Click this, click add. Under structural, I'm choosing solid. So here you have two different options like quadrilateral 4-node element, quadrilateral 8-node element. These two can be used to model 2D problems. And below here, you have a brick element, 8-noded brick element, and 20-node brick element. These two can be used to mesh a 3D problem or a 3D model. So for my convenience, I'm choosing quadrilateral 4-node 182 element. You can also choose 8-noded 183 for this problem. So I'm picking the first one, quadrilateral 4-node 182. So let's select that. Click OK. Now, since they specified thickness, no, I want to add the thickness as a real constant. Okay, and I need to define the element type. Still, it's not enough. I want to use like go to options, and here you need to define the element behavior. Because 2D problems, you have two conditions like plane stress condition and plane strain conditions. So in our case, I need to assume it as plane stress, but since they specify the thickness, I will consider it as plane stress with thickness. I will pick this option. If you don't pick this and assume plane stress, then you can't add thickness to the model. So that's why I want to prefer plane stress with thickness. Let me select this option. Click OK. So I'm done with the definition of element type. I'm closing this. Now, let me add the thickness as a real constant. So just press this real constant option, add. So you are adding thickness to the plane 182 element. So let me select this, click OK. And here you need to specify the value. So from the problem, you can clearly observe that the value is 20 mm. So remember that the lengths are specified in terms of millimeters. Click OK. Close. So now let's define the material type, material properties. Click material properties and pick material models. So the material is of structural, linear, elastic material, which is an isotropic nature. So let me add the Young's modulus and Poisson's ratio here. Young's modulus is 210 gigapascals. So let me convert that in terms of newtons per square millimeter. So it should be 210 and per 3. Poisson ratio is given as 0.25. I'm done with the material properties. Click OK to create the material. So once again, we are building a linear elastic isotropic material. So after creating the material, let's move to the next step. So I'm going to create a model. So if you clearly observe now, I need to create a rectangle. Then I need to remove some material here at the center. So I will create this based on by defining the coordinates of two corners. So I assume this center point of the rectangle as 0, 0. So you need to specify uh, the coordinates of this corner and this corner. Okay. So the length is given as 500 and width is given as 300. Okay. So let me create that. So move to modeling. I need to an area. I'm using it. I want to create a rectangle now. So I'm opting for rectangle. And here you have different types. Like you can specify by two corners, by center and corner, or by dimensions. So I know the dimensions now. I'm picking this option by dimensions. Now, when you pick that option, you need to present the x1 and x1 y1 values and x2 y2 values. So since I am assuming the midpoint at the center of the rectangle, let me specify the x coordinate as minus 250. This is x2 is y 250. So on the whole, it should be 500. Similarly, the y coordinate should be minus 150, 150. So don't get confused with this. You can follow this. Okay, x1, x2 will be specified here, and y1 and y2 should be specified here. Click OK. So now I created a rectangle. So if you want to cross check, then you can go to list. Here we have an option like list areas. Okay, so it is showing the areas that you created. Since you have only one, the area is created by combining these 4 lines, line 1, 2, 3, and 4. Am I clear? So now I need to create a circle, and after that I can subtract the circle from this rectangle to create a hole. So let me move to next option. Like I want to create under areas, I want to pick the circle option. Once again, I want to use by dimensions. Okay, let me cancel this. Let me create a solid circle. It's very simple option. So here you need to specify the xy coordinate, to specify the center and the radius. So xy, I want to produce a circle at the center. So the center coordinates are 0, 0, and the radius is, it should be 50 because the diameter of the hole is given as 100 mm now. So let's specify the radius as 50. Okay. Now I have one more area, which is actually on top of the rectangle. So let me list those the areas once again. Go to list, click areas. So now you have two, like first area is actually representing a rectangle and second area is representing a circle. See here, the circle is a combination of again three lines. Okay, don't confuse like arcs are also represented as lines. Okay, so if you want to have the numbering, then you can go to plot controls, click numbering, and here you have an option like lines. You want to view the lines, click lines, click OK. See now you can clearly observe the lines. So this is line 1, 2, 3, and 4. Similarly, the circle is a combination of line 5, 6, 7, and 8. Okay. So now let me remove the material by using a Boolean operation. So once again, under modeling, you have this operate option. Let's click this option, and here you have Booleans. You can add or subtract materials by using this option. Let's select it. Now I want to subtract the material now. I'm selecting subtract option. So I want to remove area from area now. So I will opt for areas. See here, it is showing some instruction. It's asking us to pick or enter base areas from which to subtract. So I need to subtract the circle from the rectangle now. So I need to select the rectangle at the beginning. So let me select rectangle. See, since you have two areas, one above the other, so it doesn't understand which area to pick. So if you clearly observe now, I'm picking the rectangle. So there is no need to use these options. Just click OK. Then you need to close. And here you can also cross check whether it is picking area 1 or 2. I already, by using list option, okay, the rectangle is represented by number 1 and circle is represented by number 2. So here area number 1 is picked. So which is good. Let's click OK. So now I want to see the instruction. You need to pick or enter areas to be subtracted. So I need to subtract the circle now. So let me select the circle. So I'm selecting here. See, by default it is picking the rectangle, but I don't want that. So you can press next. Once you press next, it will select the next area, which is coinciding with the first one. So I will press next. Now if you clearly see, it is picking the circle, which looks good. Click OK. You can clearly observe that area 2 got selected. Click OK to actually remove or to make the hole. Okay. So now, once again, list the areas. See, it is showing, it is naming the area as 3, and it's a combination of the rectangle and the circle. Click OK. So I don't want to show the or let us leave it like that. Okay. So after creating the hole, so I'm done with the model. So now I need to mesh the model. Okay. So in the previous case, we only discussed about how to mesh a 1D problem. No. So now we are going to create a mesh by using 2D elements. Okay. So let's select mesh option. Once again, let's check the mesh attributes. So I'll pick the default attributes as okay, element type as plane stress element or plane 182 element. Material number is 1. Real constant set number is 1. Okay, I will leave the default values as it is. Click OK. Now okay, control the size. You can go to size controls. Okay, or you can use this mesh tool option. In the previous case, we use size controls. Now I'll show how to use mesh tool option to control the size as well as to mesh the model. Let's pick this option, mesh tools. So if you clearly see now, we are dealing with the areas. So I want to set the size control. If you want to do it manually, or if you want to do it by using auto option, you can use this. You can activate smart size. Okay, you can pick this, and you can go for like if you want to create a fine mesh, just move this status bar. Okay. So initially, I don't want to opt for smart size. Okay, I'll define the size controls. So this size controls option is similar to the size controls that are available here. So I want to define the element size. Okay, so I will directly opt for under areas. I will set the value there. Let's pick this set option. Yeah, I want to assign the elements for this area now. So I'm selecting this area. Click OK. So now it is asking us to specify the element edge length. Okay. So let me pick 20. 20 as the element edge length or the length of the element. So remember that we need to create quadrilateral elements. So the one side of one quadrilateral is 20 mm. Okay, click OK. So I set the value. Then you need to mesh it. To mesh it, see here under mesh. By default is picking areas because you have areas. If you want, you can override it. But I need to mesh the areas now. So I'm picking areas. See here, I can control the shape of the element. Okay, 2D elements can be triangular or quadrilateral. So I'm opting for quadrilateral because they are more flexible. Triangle, I think you learn in finite methods, no? You studied about constant strain triangle, CST and LST, linear strain triangle, no? So you have problems with constant strain triangles because they are very rigid. So that's why I'm opting for quadrilateral option. Okay. So since this is an irregular option, since you have a circle at the center, no, I can't use map mesh. I will go for free mesh. So once you are satisfied with these settings, you can click mesh and select the area to create the mesh. So I will pick mesh option. Let's select this area. Then click OK. See, it created a mesh now. If you want, you can refine the mesh, but it looks good. I'm satisfied with this mesh. So once you create the mesh now, after creating a mesh, you need to apply the boundary conditions. So from the problem, see, this end of the bracket is fixed, and here you need to apply a pressure on the surface. Okay. So I need to define the boundary conditions. Move to loads. Okay. Before applying the boundary conditions, I want to define the analysis type as static analysis. Select analysis type. Create new analysis. Here I'm picking static as the option. Click OK. So to define the loads, I'm picking this option, define loads. So I need to apply it on this end now. So click apply. Structural. So here I need to constrain the displacements. So let me select displacements. So I will apply it on lines. Let's select on lines. I'm selecting this line. Click OK. See, now I need to constrain both the degrees of freedom, that is displacement along x-axis and displacement along y-axis. So I will pick, I want to constrain all the degrees of freedom, or you can pick them individually. So I will define it as 0. If you leave it as empty, then also it picks as 0. Click OK. So here I applied a boundary condition. So after this, I need to apply a pressure load here. So move to pressure option. Once again, I want to apply it on the line. Let me select this line. Click OK. Now I need to represent the value here. See the intensity, it is defined as P equal to 1 Newton per square millimeter. Okay. So I will pick the value as, see, if you don't view the window, no, just press this, then you'll have windows that are not visible to you. Okay. You are applying a constant pressure and the intensity is 1. So if the pressure is varying over the length, you need to define another value here. But since it is uniform value, the pressure is uniform over the line, I'm opting as 1. See here, always remember that when you apply pressure now, pressure is always applied towards the surface. Okay. So that means pressure load will be applied in this direction if you specify it as 1. Okay, it's always towards the surface. So the value should be -1. See here, you are actually pulling this. Okay, so the value should be -1. The common mistake that you make is instead of -1, you will put it as 1. Okay, so always remember that pressure is always applied towards the surface. Okay, the surface is represented by the line. So that's why I'm opting as -1. Okay, click OK. You can view the direction. Okay, so let me save the database. So if you want to list the elements, you can check the properties like elements. I want to pick, I want to represent nodes, attributes, and the real constants. Okay, I want to pick this. See, these are the, so the thickness for all the elements is 20. It is specified here, and element type is 1. Since you have only one element, it is picking that element type is 1, material type is 1. Once again, real constant type is also 1. Okay, and here is specifying the elements. So on the whole, you have 359 elements. You can also observe the nodes related to a particular element. See, for element 1, nodes are these 3. Am I clear? You can cross check it whether it is picking the correct cross section or not, thickness or not. Click OK. So this is a simple problem, and you have only the material type is only 1. So that's why there is no complexity in the problem. So after this, after creating the boundary conditions, now I can solve the problem. We already created the analysis type now. So move to solution. Okay. I need to define the analysis type. Let me select analysis. Yeah. We already selected it now. So leave it like that. Directly move to solve option. Let's click this. I want to solve the current load step or the current load step. Select current load step. See here. So the problem type is 2D. Okay, the degrees of freedom that we are related to is UX and UI. So in the previous case, in case of beams, no, you have 6 degrees of freedom. UX, UI, UZ, and rotation with respect to X, Y, Z. On the whole, you have 6. For a bar problem, you have only 1 degree of freedom, 3 degrees of freedom now for each node. UX, UI, and UZ. But in this case, since it is a 2D problem, no, plane stress problem, each node has only 2 degrees of freedom, UX and UI. So the analysis type is specified as static, steady state. So you will get a symmetric matrix. The global stiffness matrix is symmetric. Okay, and you are applying the load in one step. So I'm satisfied with everything. Then click OK to solve the problem. So it says that the solution is done. Since it is a simple problem, it takes very less time. Let's close the window. Now you can go for post processing. You can view the stress distribution for this bracket. So let me move to general post processing. Initially, I want to show that I want to view the difference between the original bracket and bracket after deformation. So I will compare both the brackets, both the conditions. So move to plot results. I want to plot the deformed shape. So since I want to compare it now, I will go for the last option, deformed plus undeformed with edges. I'm picking this option. Click OK. See this dotted line now is representing the original model. So which ends here. So this is the original shape, and since you applied a pressure there, it is actually deforming. And see, the position of the hole, it looks like a circle, but now it looks like a ellipse now, so due to deformation. Okay, you can use counter plots to check the stresses. So I'm using counter plot option. Okay, so initially I want to have a counter plot of the deformations. So I'll go for nodal solution, degrees of freedom. So I will pick displacement. Okay, I'm picking the vector sum. Click OK. See, the maximum deformation is 0.0028. So since we specified the dimensions of the lengths in terms of millimeters, this value or the total the maximum deformation is 0.028 millimeters. Since you fix this end, the deformation at this interface is 0. Okay, naturally the deformation will be maximum at this interface, which is specified by this value. Okay, so let me have a stress distribution for this bracket. So move to element solutions. I'll pick stress. Okay, you have so many options. I prefer the Formier stress distribution or the equal stress distribution. Let me select this option. Click OK. Okay, so if you clearly observe now, the stress is maximum at this interface. Okay, and the maximum value is about 3.25 megapascals because you specified the forces in terms of newtons and lengths in terms of millimeters. So the total could be 3.2 Newton per square millimeters or 3.5 megapascals. You can also check the principal stresses if you want. Here you have so many components. So I can choose like principal stress along direction 1. Okay. So this is how you can solve a 2D problem. Okay. Any doubts? If you have doubts, you can put it in the chat box. You have doubts?